Hello everyone, Mike Levin, Wednesday, August 23rd, 2017, around noontime, and I'm walking here on Lexington. I figured I'd get the Chrysler building in background for a change, and the reason I'm shooting a video during lunch, something I sometimes but not too frequently do, is I need to just walk and think through some of the latest things in my head on my current work. And there comes a time in the life of a lot of projects where all these files you're mixing around and organizing start to take on a general shape, a shape that shows you that what you have is a hammer if only everything looks like a nail. You develop a solution to a problem, a tool for addressing a certain class of problem, and the temptation then is to extract part of it and have it as a system for that type of work whenever it comes up to make things go a lot faster. So probably the most glorious example in recent years has been Ruby on Rails, which was an extraction out of a internal project by the company who invented it. I always forget the names of these people, the company name and the person. They all have strange names, but basically it was either Basecamp or Backpack from which the Rails framework was extracted, which actually made Ruby so popular. And there's a few ways these types of general frameworks work. I'm choosing my direction now mostly for interesting or different scenery. No particular goal in mind. I'll probably grab a lunch to take back with me to eat at my desk or something so that I actually do eat on my lunch break. But the main purpose is thinking this through. So projects often evolve into more generalized systems, so that when that same project comes up in a slightly different form, you can just crank out a solution. And oftentimes these are called frameworks because what you're doing to reduce the amount of work is you're collecting up all this code that could be all over the place, and you're putting it in one place and making it handling a bunch of different cases, and then you feed it something like a config file, which is why these types of frameworks, especially the Java ones, have a reputation for massive config files, oftentimes XML, which is just about the hardest stuff to edit. And by the time you're done, you've just shifted where you need your knowledge and expertise from the all-purpose general programming language, which will always be useful to you, to a specialized config file using various conventions and stuff that needs to be documented and understood in a specific sense. This framework requires this and this and that about the config file, and then suddenly it'll all just magically work and make sense because the thing you're feeding it to is expecting. It's an actual military Hummer. That's pretty cool to see. Just parked there. So generalized frameworks oftentimes have config files, and Ruby, one of Ruby's interesting ways of handling the fact that not everyone likes config files, especially when you need to start overriding the conventional behavior, is code generator, where it outputs all the scaffolding. And the scaffolding is all the Ruby code that would need to be there as if you were not using Ruby on Rails and there was not some big interpreter sitting somewhere going, here's how you do stuff in general with when you encounter this type of initial conditions. Instead, here's the wholly built application with a bunch of Ruby files that are ready to be overwritten. And Python has its share of those types of usually web frameworks. I think Pylons and Turbo Gears. There's a bunch of ones that generate code. Oftentimes these are called code generators in other languages. It's a little confusing in Python because generators have this efficient, forward-only memory, almost like a SQL cursor aspect to it. which lets you handle massive amounts of data without large objects in memory. That's a Python generator, not to be confused with code generators that spit out the scaffolding files from framework systems as a good starting point for creating customizations and modifications. So you can vary it radically from what the original on Rails set of rules allowed. So anyway, that was a lot of talking to say that what I'm doing is I am avoiding building frameworks. I am avoiding building something that needs a complex config file. But rather, given my premise that Python is the framework, it should in fact be possible to to have what is effectively a configuration file, but instead of mysterious conventions that are going to be carried out according to some file off hidden somewhere, it's just the code of the program is the config file. That is the program. If there's, CRUD events happening, create, edit, delete, record or record, you see it right there in the config file because the APIs are beautiful enough that you can define everything you need to do right there and just look at it and understand it. I am relying significantly on the elegance of Python and the briefness of Python so that what looks like a config file is the code of whatever's going on. Oftentimes it's reports, so you don't have to deal with the updates and deletes and stuff. But actually the updates you deal with a lot, just not a fully interactive interface. It's for building stuff that runs on that whole batch file type system, where you start out. So I'm creating a file which gets scheduled, and every time it runs, it does something quite sophisticated. You might think of it as painting data onto the screen to create a picture. And it's very tempting to create a framework. Everyone's favorite sport in Python when they start to learn it is to create a framework, because it takes you, like I used to say 80% of the way, but no, Python brings you like 98% of the way towards having a general all-purpose framework, and you just put that final 2% in on making your own particular instance. That's why projects like bottle.py, a single file which is a whole web server, are so popular, because you can just load it up and read it in one file, everything that's going on. Now, the very big concession in something like bottle.py is they went from a single file with no dependencies out of Python's own core libraries that get distributed and installed with Python to including the same dependencies as Flask uses. Namely, I think it's Workzoid, the thing that handles routing in the Flask web micro framework. I'm rambling a bit, but the point is that in order to make these small single files do so much, you include third-party packages of various sorts. Maybe something for some customized logging, maybe something for handling Google OAuth login, maybe something for interacting with Google Spreadsheets, so you can start to use Google Spreadsheets like a generic database with all the same CRUD capabilities people are used to from Ruby on Rails type apps. But suddenly Google Spreadsheets is your database backend, and quite reasonably so, because it's just the right amount of lightweight data that can so easily live inside a spreadsheet. You have to be careful then, because all your database rules change a little bit. Instead of allowing a Google spreadsheet to get stuffed and stuffed and stuffed with more and more data, you have to make sure you fill it up intelligently, splitting data correctly between tabs, and when the time comes, it prompts you to create a new file, or maybe it creates a new file on its own. I believe gspread lets you do that. There's so many interesting sub-nuanced points here, but I'm getting ready to grab my food, and I think I'll wrap it up there, with the final parting shot being that The thing I'm thinking through is precisely how to keep such a system incredibly lightweight so that a single config file isn't doing too much. It's not even a config file, it's the program. So the place where you start to break things up and make sure it isn't so big is at that level. So I have a series of these files, which one and then the other and then maybe a third get run in sequence with certain dependencies. One has to be run first, the next has to be run the next, and the third needs to be run third. That way you can hit different data sources for each one and do all sorts of joins and sort of build up a picture. And by the time you're done, you only have 3 easy Python files to manage, maintain, look at, make edits, changes, a couple of Google spreadsheets that you have to keep in sync by making sure you don't create column incompatibilities of some sort if you're using placeholders or labels or magic numbers. And then the complexity of reports. The complexity of complex reports is hidden by painting it onto the screen in multiple passes, at least in the case of the one I'm doing now, which I think will be a common use case, the equivalent of SQL joins across systems. But many joins, there's a bunch of joins from this one data source, and that becomes one file to maintain. As soon as you're touching a different data source and you're handling dramatically different response object structures, it has its own complexities that need to be dealt with and isolated on its own terms. And even if it needs to join to this data that was created in that first thing, you can do it after the fact by selecting whatever columns are intended to work as the primary key or unique constraint columns for the join. And you have all that left inner and outer and all the happy stuff you have in SQL, but now generically from any data source in Python and with complete freedom from all that sysadmin nonsense of, or I should say database administration nonsense. You're never going to get away from being a sysadmin a little bit, but you can get away from being a database admin by leaning on the cloud and local cache files as appropriate a lot, and just restructuring your request, your ask, so that you don't need heavyweight, expensive, difficult to manage and maintain database layers or other components that makes it expensive, brittle, and the list goes on. You keep it lightweight. You work on stuff that you can call middleware that runs on some easy to administrate, cloud servers. And I guess that's the parting thought there. Those lightweight cloud servers running Python middleware are not called upon to do much heavyweight stuff except what's defined in these series of small, easily understood Python files that can be strung together for single report output and then strung together in scheduling for painting a whole mural every night, or every week or every month, what have you. So there you go, Data Master moving into 102 if all the stuff I've been doing so far is 101. Is that how the numbering system works? 101, 102? Well, whatever. Thanks for joining me. Hope to talk to you soon, and don't forget to subscribe.